Greetings, friends and enemies. My name is John Gabriel. Welcome to my new calculus channel. And today I'm going to be talking about the modern Greek perspective of the ancient concepts of magnitude, ratio, and number. So let's begin. Now, if you do a search, like for example, what I've here said, difference between number. You'll get a lot of it you can see here. And the video I'm going to be talking about is this one here where I'm pointing to. And I'm going to play a little bit of it and then show you why the perception of the concepts is totally wrong, and that modern Greeks don't really understand the difference between magnitude, number, ratio, and it's taught completely wrong at schools. But the funny part is this, this particular presenter starts off correctly. So let's listen to what she has to say and then continue from there, just a minute or two.
Το τελευταίο μας μάθημα και αφορούσε τους λόγους. Τι είναι οι λόγοι? Οι λόγοι είναι η σύγκριση, η σχέση μεταξύ δύο μεγεθών. Σήμερα
So she says, what are ratios? They are the comparison of two magnitudes, megathon, and what relationship, what schesi, in Greek, schesi means what relationship do they have? So she says, she actually defines that pretty accurately, because in definition 3 of Euclid's Elements, it says, λόγος esti δύο μεγεθών homogenous ή κατά πηλικότητα ποια σχέσεις. So, you see, it's almost correct, and one can see from Euclid's definition here that modern Greeks have missed out a lot of the meaning of this particular definition, because what this says here is a ratio of two magnitudes, two homogeneous magnitudes, by the way, not just any magnitudes, but homogeneous, or is actually a comparison between the two, or the quotientness of the relationship. So, for example, a ratio can possess quotientness or not possess any quotientness. Now, in Greek, the word for quotientness is pηλικότητα, and of course in English there is no such word as quotientness, but I've made that up because that's what πηλικότητα means. Do the parts of a ratio have a common divisor or magnitude? So modern Greeks don't understand these things, and it's pretty evident if you have to continue watching this video, which we won't, is that this instructor tends to differentiate between λόγοι and αναλογίες, but they're actually the same thing. Λόγοι are ratios, and αναλογίες are just equivalent ratios. In other words, what that means is ratios that are in proportion. But she totally ignores the fact that a magnitude is not a number, and she just transfers the property, which one is allowed to do. But there is really no difference between λόγοι and αναλογίες. Okay, they're both ratios. They're both λόγοι, which is plural for ratios. Logos is one ratio. So modern Greeks don't understand these things, and of course it's seen by the example that she starts to show on the board. So even the example says it's a comparison of the weight of a chocolate and the number of calories, and here we don't have magnitudes, we have number. So what is the Greek understanding of magnitude and number? It's that they're both number, but Greeks don't really even understand that in book 7, where number is formally defined, there is no difference between a number and a fraction. Okay, so the first definition says a unit is that according to which each existing thing is said to be one. That's really a very bad definition. Okay, Euclid didn't think about that one very carefully, but the right way to say that is that a unit is a ratio of equal magnitudes that is used to measure other numbers. Okay, so for example, definition 2 basically says that we have a special kind of fraction. Yes, it's a fraction, by the way. Definition 2 is talking about a fraction because whole numbers and natural numbers are fractions. And in book 5, we can derive all the arithmetic in geometry, which is exact, by the way, unlike algebra. And we see that in geometry, a ratio can be used in any of the 4 operations. But the measure of a ratio is what gives us a number. So if we have a ratio of equal magnitudes, its measure is called the number 1. And it's formally written as over 1, right? It's formally written as 1 over 1. And 2 is formally written as 2 over 1. But you don't see these written as 2 over 1 and 1 over 1 anymore, because it's understood that if you write 2 by itself, it means 2 units. Every number, without any exception, is a fraction, okay? And so modern Greeks don't understand these things. And they tend to confuse the relationship between magnitude and number, and also they tend to think of fractions as being different to number. In fact, to be a number, the object must be a fraction. So the Greek word for fraction, which is klasma, is in fact totally unnecessary. Because if you look at definition 3, it says a number is part of another number, the lesser of the greater when it measures a greater. And obviously the converse is also true, that a number contains another number, the greater of the lesser, when the greater measures the lesser, okay? When parts of the greater measure the lesser. So to be a number means being a fraction. So the word klasma, or fraction, is really redundant, okay? And a number is the measure of a ratio, very simply put. So, for example, let's have another look at this. If we have a ratio like this, okay, we can't say that that's the same as a particular number, because it may not have a measure. What if this is the circumference of a circle and this is its diameter? What are you going to write over here? Are you going to write pi over 1? I don't think so, because pi is not a number. Okay, pi is a constant that is realized when you try the circumference of a circle using its diameter. All right? So, what I'm telling you right now is that it's unfortunate, because if any people should understand these things, it should be the modern Greeks. And ironically, they tend to quote things more or less correctly, but have no understanding of them. So you can say that, for example, in geometry, that ratios are in proportion, meaning they're equal, because they can be in proportion without being equal. But that's not the case in algebra. In algebra, we don't care about the antecedent anymore of a ratio. We look at the entire measure. So, for example, the measure of 1 to 2 and 2 to 4 in geometry, in other words, by line segments representing or giving rise to those measures, that is not the same in algebra, because they're equivalent. We only care about the measure. We're saying, look, don't worry about the consequent anymore. Doesn't matter what is the size of the consequent. All we care about is what is the measure of the ratio. So I hope you've learned quite a lot of things from this, and that you will download a free copy of the Elements and study it as you see in front of you, and realize that what I'm telling you is the correct information. Most of your teachers, in fact not most, all of your teachers and lecturers do not know these things, and they have no clear understanding of what is a ratio, a magnitude, or a number. So, if you're not already a subscriber, please become one and spread the news on my channel and donate dollars and credits on my Odyssey channel. So, I'll be talking to you again soon. Till next time, goodbye.